right, we did it. There's a little bit of sorry about that. Next time it's going to be faster.
Don't worry, it's good that's working out.
Yeah.
So
all right.
First, thank you, Vizu, for doing this presentation, sharing this share about code testing and providing a moment for discussion. Thank you so much. And let us start, please.
Okay. All right. Hello, folks. So basically today, actually, I should probably. All right. That's the presentation form. Okay, so they're invisible. So today we're going to talk a little bit about Go testing because it seems that we do have a problem with our tests. So, we're going to discuss some considerations, best practices, and generally ways to make our testing better. Okay. So, first, before we even start, we need to, be explicit about why we test, right? It sounds self-evident, yeah, the code has to be tested, but why are we testing? Why are we writing tests? So basically, there are certain things that we want to get out of a test, and this is one. Input-output specification of the unit, component, system we're testing, whatever. Given an input, the system must produce this output. Okay, this is one certain things that we need to test. So we also need to do this for the entirety of the public interface of the component or the unit, right? If there is a public function in the unit, then it should be tested so that the input-output specification is met. Okay, and what this means is basically at the very minimum, we need to have a test that says the happy path works. So, in the absence of errors or any strange behavior, given this input, the system should produce this output, right? But of course, this is not enough. This is just the baseline. If there is no test about the happy path, you don't know if the code actually works at all. You have no confidence. So, but that's not enough. We also need to check certain unhappy paths, not necessarily everything, because some might be very hard to trigger as long as, we test something with error paths in there. Basically, we have to make sure the system, the component doesn't fall flat on its face, panics, or otherwise throws a tantrum, but it basically, it reacts and responds in a grateful manner and returns an error. Okay? These are fundamental properties, and these are the desired properties from tests, right? We're trying to make sure that, as far as the component or the unit is viewed from the outside, there are no bugs. But of course, we only try to do this to the best of our ability because you cannot prove the absence of bugs. Okay, all you can do is increase confidence by having covered the code in a sense. Okay, I think this is self-evident. So, but obviously, there are more tests, right? We want to do there are additional desirable properties. So, first of all, we're going to make sure that the unit is robust to errors. That means that if something goes wrong, as I said, it doesn't fall flat on the face. But this also includes programming errors. Maybe somebody used the interface wrong, right? Used the API wrong. It still shouldn't crash. It should be, it should react in a graceful manner. And you also, sometimes when the unit is exposed, to input from the network. So then we have to consider adversarial inputs as well, because yeah, it's the internet. Someone's going to attack you, eventually. You can't avoid that. Okay, and final property is, but this is usually not part of unit testing, but it's still a property that's important. Basically, we also need to make sure that the system performs adequately. There are many ways to handle this. You can do some micro benchmarks with unit testing in Go with the benchmarking interface from testing. But this usually takes harness tests that are more complicated, situation because it's not enough to just micro benchmark some things. Maybe something simple enough to micro benchmark, but at the system level, yeah, you need to simulate network latency. So it's not something you can do easily with unit tests. You still have to do it though. Let's not forget it. So basically, we've already sort of covered that, but I want to think in two types of tests, like basic tests that you can do with underscore test.go files, and things that require setup, right? And here we're going to be focusing on the basic tests. So what kind of basic tests we have? We have unit tests. So basically, it's a particular file, it's a particular module internally. It has to cover the code there. The functional test, where basically you cover the code at the package interface, Go, right? Only public interface. So the unit test is allowed, like to inspect the internal state of the objects it's dealing with, like break private, package variables, because it is inside the package, and its purpose is to make sure that among other things, that the internal state stays consistent. But on a functional test, and this is the distinction from the unit test, is you don't access the internal state. You only work through the public API of the package, basically. And once we have that, you need integration tests, which basically cover code that cross package dependencies, like an integration of various components. And another type of basic test is that we don't have any at all, I think, right now, but we'll start seeing them once we start having bugs reported and fixing them. Basically, it's regression tests to, like if some bug was discovered, you should also add a test that basically check that the test fails before the fix, the test succeeds after the fix, and basically it's there to make sure that in the future when you make changes, the test still passes and you don't have the bug anymore. Okay. Again, there are some other tests. Probably they're more complex. You don't typically put them in an answer test. So, for example, the fast test. Okay. Generate random adversarial inputs, feed them to your code, see what happens. Obviously, this is not something you do in a unit test because by definition it's going to be non-deterministic. Okay, but we still need, fast tests for certain components. So, for example, if you have a parser, you should feed it random input and see how it crashes, because all the parsers pretty much crash in the first time you feed them, adversarial input. So again, performance test and system integration test. So this is even higher than integration, but then this is something you can do with the CERNES test, so that basically you get the CLI, you run the command basically that starts your system, and you interact with the CLI. So these are system level tests. Again, not _test.go. Okay. Any questions so far?
Well, I have a question regarding the basic tests.
Yep.
And I think because basically, so functional tests and integration tests, I think we don't consider basic tests in our case, because for that we have to have a built already DMS.
We're going to talk about it because we should have this kind of tests that basically use a test kit, and basically you can test the system without necessarily having to start, like an external process. You can test it from within. So this is something I'm going to discuss a little later. But we should have this kind of integration test. Basically, the integration test shouldn't be, take the binary and do that, because that's a system integration test. The integration test should be built internally, simulating process binaries by having multiple threads of control going in the context appropriately, and basically run the test in there. So this is something we're going to visit a bit later when we discuss about the focus on the ITest situation. Okay, so let's focus on basic tests, because this is what we're mostly be concerned about, in our day-to-day programming lives, right? So there are certain things, basically test quality. That's something we're going to discuss. It strategy for tagging tests, so that you don't have to run the entire test suite, that may take like several minutes to run, but you only run things that you care about. And there's going to be, a bunch of recommendations about, best practices. And of course, we can't avoid discussing a little bit about CI/CD rules. So quality, right? Crappy tests are the worst thing that can happen to a code base. They bring down velocity, because you have to deal with fixing the test all the time, and you can't change the code because all the tests are breaking, and you have to spend like 8 hours fixing the tests, and you're cursing all the time that you're doing that. So you don't want crappy tests. We don't want flaky tests that are unreliable, and basically you don't know whether the code actually works if the test randomly fails, right? So this is a flake. Okay, so basically, we can state these properties that we want. Is like the test must be deterministic, right? So always either pass or fail, no flakes, modulo the occasional cosmic ray that will happen once a week, and cause some random failure. Who knows? Okay, but you need to have like 1 minus epsilon, confidence that the test is going to pass. All right, but if you do run into a situation where the test is flaky, and we will, maybe the test is flaky, but maybe there's actually a race condition in the code. So the way you must make it deterministic, but if you start seeing where suspect race conditions, you need to run your tests with go test plus race to basically to see whether it finds something. And usually if you start having this kind of flakes, it might find something. There are cases where it has uncovered serious bugs. Okay. And the other part is that once we accumulate test, well, please don't test the same thing. I mean, if we already have a test that covers a code path, don't add a second test. It doesn't add anything. Okay. And your last but not least, like I said, grab tests, are the worst thing that you have into a code base. So, the test must be easy to understand and maintain, right? Don't go wild building abstractions, like to write a test. Keep it simple. Okay, even code that you would not push in production, stupid code, but like as long as it's easy to understand and maintain, that's what you're going to do. Otherwise, you just screw technical debt. Tests are not a panacea. It can be a serious problem. If you have like a really poor test base. Okay. So, any questions here? I think I can't see everyone, so it's hard to tell if anyone has a question. So please feel free to interrupt me if you have a question. That works much better than me stopping and asking any questions all the time, right?
Okay, sorry, I have a question. I couldn't understand very well what does it mean a test is flaky. Sorry.
A test is flaky. You've never encountered a case in CI where you have a test that sometimes randomly fails?
Yeah.
Yeah, that's a flaky test. Basically, a test that you run it locally, it passes, and you're happy, and then you push it in CI, and then it fails. Like maybe 1 out of 3, or maybe 1 out of 2, or who knows how many times. And then you're scratching your head what's happening. It's probably something that has to do with timing, something with a different environment. When CI, like there is something there. So there is a probability of race condition, or maybe the test is wrong, right? You didn't write it the right way. So either of these can be true, and you have to test for this. To basically fix the test. If you find the bug, even better, fix the bug.
Yeah, sure. Thank you.
Okay.
Yeah,
Right.
Viju, I have a question. So regarding the previous slide, you shown that the functional test will also be covered in the Golang.
Yeah. The functional test means, like this is the module, and you're going to test the public interface that it meets the functional specification, on its own, what's input outputs. And, we're going to talk a little bit about mocking. Usually you might want to do some mocking, if it has dependencies to other components. But the point is that I give you Go packets, then, the input output interface needs to be testing, all the capital case functions should be tested.
So Viju, my point is, in the testing terminology, we say the functional testing are those testing which are performed from the user perspective. For example,
Oh,
the
yes,
testing...
yes, like that's absolutely true. But think about it, at the level of a module. Who's the user? He's another programmer. What is the user going to use? The public API. So you need to test, and and if you want to test about the end user, usually the end user is not concerned, with actually the low-level API. So he's more concerned, or he's more concerned with the higher level interface, right? The system interface as a whole, because the end user doesn't care if function do probe fails intermittently. All he cares about is that he clicked the link on the web interface and nothing happened.
So for example, currently we are following the Python and BDD based framework for our functional automation. Okay, so do we need to switch our automation framework from existing one to?
No, you don't have to switch anything. I'm not recommending switching anything. If you have a framework in place that actually performs functional testing from the point of the end user, that's great. Please keep it in place. I'm not suggesting that.
Okay, yeah, I understand. Actually, I was confused by saying the functional tests. So functional tests are since we already have a
I
for
understand the
that.
confusion. I'm talking about the functional test in terms of the module that you're building, right? So you have like a directory, like in your Go code base that has like 10 different files that comprise the module, and a bunch of them are public. So the user in this case, for the functional case, is the programmer. So if a programmer, you need to see what the programmer wants to do with that, what the public interface says. And and basically cover that.
So Viju, in generally in this context, we say when we are dealing with the interface testing and module testing, which is inside the code base itself, we generally pronounce it as integration testing.
It's not integration testing. Integration test means you take multiple components and you test how they work together, right? That's not integration test. That's a functional test.
Okay. Okay. Yeah. Thank you.
Okay, yeah, but Kabir is right because it resolved the nomenclature because this is the nomenclature right now. But well, maybe we have some differences in how we call our tests. So take this, fuzzy. So try to match it to what we have, and we should definitely resolve this. Kabir is right. All right. So here's a neat trick. It's called the test tagging. So basically, you have different types of tests. Like functional integration. Unit tests. This usually, functional integrations are usually not slow, but integration tests tend to take time and resources. Okay, and you also want to separate the run, given in CI of the integration test from the unit test and the functional test. So the trick here is you use a build tag, and you put it, like in this magic comment, at the top of the file. Okay, and basically when you just do go test, it's not going to run the integration test. So if you want to run the integration test, you do go test tags integration, and then it runs them. Okay, so I don't know whether we're using it yet, but I think we could use it. Any comments?
Is this only for separate integration tests and unit tests? This test tagging.
The integration, you can use it for anything you like. So if you have like specialized tests, it's very general. You can put any tag you want. Okay, the tag is like almost a free-form string. It must be a language identifier, but it's otherwise a free-form string. And basically, if you want to separate two tags like expensive, although there is another trick we're going to look at later, basically put whatever tags you like. But I suggest that we have tags for integration at the very least, so that these tests are run in a separate step in CI, and basically we can see whether the unit test failed or the integration test failed. Because a unit test failure means there's some shallow bug probably internally in the module that you got to fix. The integration test might be like a deeper bug that you need to figure out how the various components interact. So it makes sense to have a separate pipeline so that basically you say, okay, the unit test all passed. I don't care right now about the integration because I'm still hacking in the module. Then of course eventually you're going to have to care about the integration. If they're still failing, then you know that there is some deeper bug in the interaction that you got to fix. Right? There was a question typed. Let me go to the chat here. Okay, if a program is a programming language, functions basic built-ins like a function, it should, yes, it should. Like the functional test should test all the built-ins that are part of like the public API, not the undocumented built-ins. Those the user is on his own if he's using them. All right, let's move to the next slide. Here's let's start. I'm going to start making some recommendations about how to write tests. So the one, it's absolutely golden recommendation is use Testify. I don't know whether you've used this library, but it's invaluable. It's a very nice DSL. We're going to look at a couple of examples later. It has mocking support, and it's also de facto standard. Pretty much all projects are using it in the open source sphere. Okay, so it's simple. Just import stressor Testify require, and let's look at some things you can do with it. So, for example. Yeah, before Testify, that's how, the red thing is how we were writing, like tests for failure, okay? And you could get, like a message that basically printed the message of the error, and often you would scratch your head about what happened, okay? Where did this come from? So basically with require, you can just, like new error, T, do something. First of all, you notice that this has much less visual noise, so that's much easier to read. Like your fingers also don't have to stretch too much to type it. And basically, you also get context about the failure. You can put anything behind multiple arguments. It's like do something. This where this is my current state, so that you can debug the test and find the bug. Okay, and here's another one. So. Well, like quality test, or this could be like X equals Y as well, with the equaler interface. But basically, just do the bottom version, require equal. You'll be surprised because when like something's unequal, it's going to tell you where it is unequal, and it's going to help you a lot with finding the bug. You're not going to have to scratch your head. Okay, and again, this is visually nicer. Like less noise, easier to type. There's tons of them. So just go to this link. Like here, and explore. This is the recommendation of the packets. So sorry, what was it? I didn't see the chat. Better than assets. What do you mean by assets? It's another library. I think this is basically
asserts, not assets. It was my typing error.
Asserts. No,
It's a
they are
cell.
assertions. Yeah,
It's a cell.
require is an assertion that fails the test. It calls default. There's also testify also supplies, like an assert module that has the same, like DSL, but it doesn't fail the test. It tells you whether it asserted or not and prints a log, basically. But typically you use require because you want to fail the test. But if you want to test multiple things and test the fail the test later, you can do assert, yes. All right, another recommendation. So let's say that we have a bunch of tests that have, like set up and tear down. All right, so you need to set up some environment, pass something, to the function X who does the test, etc. Okay, so one way, the primitive way, is to write all the tests separately, repeat, do setup, do, defer, do tear down all over the place. You don't have to do that. The testing library provides, the ability to group tests together, and they're displayed very nicely where the errors are there. So just write out, basically set up, write your setup code, call trun a few times for the various things that you're testing, and write your teardown code. That's the way to do it. Since we're talking about tests taking a long time, so this is also a nice trick. Basically, you can have, if a test is going to take like 30 seconds to run, okay, and you're not concerned about it failing right now because you're not working, like in this part of the code, or maybe you just want to defer testing until later. Okay, you can add a little bit of code and test. Okay, if testing is short, basically skip it. And when you invoke go test sort, like to run the quick tests, to see whether you introduced any bugs and some changes you're making, then it's not going to run. And here's a recommendation that's a personal piece. Please, for the love of God, well, go do it. What's the difference, right? Like do not parse error strings. That's the worst thing you can do, because then you have a typo, you fix a typo, and 30 tests broke because you were passing the error screen. Just use named errors and errors. So when you want to add context to an error, you use like FMT error F, and with percentage W modifier, and you pass it the error that you're going to wrap. And then you can test whether this is an error wrap with this error is. Basically, it's the function form, if you want to use in general, is errors.is. But this does the requirement that tests that like you failed with what you were expecting to fail without doing like nonsense like parsing the thing. So please don't do that. It drives me crazy when I say it. And don't laugh. I've seen it many times. Yeah, there are several. No, so assert, you mean, like the module of testify, right? Like again, I prefer to use require instead of assert because it fails the test immediately. Like it's preferable most of the time. All right, so these were some of my little hints, but like there's another one when it comes to scope control. So you've noticed that the tests have a package declaration on top, right? So unit tests, you put them on the same package so that they can access internal state. But if you're writing a functional test and you don't want access to the internal state, then you can put it on a different package. Go allows you to do that. Okay, so you put it on different packets and just use the public exports, and you cannot access the internals either you want it or not. Okay, and when it comes to integration tests, I think the integration tests should not live next to the code or the units, but have a specialized directory near the top. For example, iTests or something like that. And we're going to talk a little bit more about this, where all the integration tests live. Okay, and when it comes to integration tests, I've been talking about this notion of a kit, right? Basically, these integration tests are going to have set up to down, like running multiple nodes within the process and everything. You shouldn't have to repeat yourself every time you want to write such a test because it becomes a pain, and you shouldn't have to reinvent the wheel, right? So we should develop a test kit for the integration tests. And I'm going to give you an example of such a test kit, right? Here, this is, the iTest from the log2's Filecoin demo. Okay, so I worked quite a bit on this code base, and I think the iTests are done very well. So, for example, there's this directory kit where it has defines a test kit, right? It has a mock miner. So if you want to start a miner, then it gives you the ability to create a miner without having to worry. Right? This is a blockchain client, remember. Okay, so here, if you're going to do something about the VM, right? So actually, this code that I wrote in the kit, this is funny. Yeah, basically, this is part of the test kit so that you can put contracts there and test outside. Okay, and if you look at how a test looked like, Okay, there are several, you know, like tests around here. So which one do I open? Let's try this one. Yep, I think I wrote this initially. I don't know, you know, like what has happened. Let's see, blame. Did I write it? Raul? No, it wasn't me. It was Raul and Magic. All right. Oh no, I think I might have wrote the original test and then it morphed. All right, because it was one commit for me. Yeah. Anyway, let's look at the code. So we want to test that, you know, we can deploy, you know, like an EVM contract into the file point, right? So here, first of all, we'll import the test kit. Okay, and you see here we do things like kit ensemble minimal, which basically creates an ensemble of hosts that basically gives you a client and a miner. So you can do much more complex thing. And there you can say miner, you know, in this ensemble to interconnect these nodes, things like begin mining. And then you wrote the rest, you write the rest of the test. Okay. So does this make sense? You know, like look at how streamlined and simple the test is, even though it has really complex functionality in there. So you have to install the contract, create an Ethereum account, you know, like send some funds, verify balances, you know, look at all these things that you have to do. And, you know, it's a really simple and maintainable test. Okay. So that, if you're gonna deep dive a little bit more, you know, if we have some more time, but as I suggest that you go, you know, like and explore on your own, because, you know, like it's a pretty decent code base, I would say. Questions here?
Just note from me. Can you hear me, by the way?
Yes, I can hear you.
Yeah, so basically, just to make it clear, the idea of this is to it's helper functions that will help you.
It's a whole module. It's not just a bunch of functions. You know, it creates a small environment so that it makes writing tests easy, because integration tests are going to be a lot of them, right? You know, and you can't make a mess. You got to, you know, make your tests pretty in this case, because otherwise they're going to be unmaintainable.
Yes, but my question is this kit thing. I'm not familiar and I haven't heard about this type of things. I understand that basically the idea is to set up the dependencies and provide some functionality, whether they are helper functions or some methods on top of your, let's
It's
say.
more than that. What you say is correct, but it does more. Basically, it mocks, connects networks. I mean, it's not just setting the dependencies, it's setting the environment and gives you an environment object you can use to basically start exactly what you want to start from the dependency, and then be able to write the test without having to think about or clutter the test with all the details of the setup and the environment. So, but yes, you know,
Yeah, we're talking about the same thing. Yeah, sure. Okay,
yes,
I got it.
you're right. It's slightly more nuanced than that, but yes, it's the same thing. Any other questions? Okay, let's move on. We're almost there. So, okay, go ahead.
Question, not sure that's related completely, but can we do tests which live in another repository?
Yes, but you know, they're not going to run on CI/CD, right?
Well, it depends on the acrobatics of CI/CD, but
yeah, it gets complicated, because then you have to have an axon that basically sees the push of a PR, you know, like, or you know, like a push in a branch, and then it starts a workflow. You know, like, yeah, we could do that. We could do that for integration tests, but I would prefer it to be in the code base itself in a separate directory.
Okay, understood. Thanks.
Yeah, it's a matter also of discoverability, right? Because you go, you know, into the code base and you don't see, you know, like the integration test at all. Where are they? You don't know about this integration repository. Okay, so since we talked about mocks, you know, like, and phony things that pretend to be other things, so they're powerful tools, right? Because, you know, like you have something that depends, you know, like on another system, you know, like, or process, and you just mock it and you give like you don't have to run all the code or even instantiate or anything. You just give the results, you know, like according to what you specify from the quiz. But there is too much mocking. And, you know, like if you end up mocking everything around you, basically you're not testing anything that cannot be tested in a unit test, and you just made a mess. So, and not, you know, like 100 lines of mocks to do something that you should have a unit test covering. So again, bad tests, you know, like remember, crappy tests or technical debt. So let's avoid those. Okay, so always make sure that you test something and you test at the appropriate level. So that's the recommendation here. And again, I'm here at my final recommendation. Please, guys, keep it simple. Remember, like there's no need to go wild and invent abstractions if you're writing a test, unless you're building a test kit for integration tests. In this case, yes, go wild, invent abstractions, and everything. But if you're writing a unit test, like simple, like I want to read the code and I don't have to scratch my head for like 20 minutes about what it is when, like I just changed something somewhere, like and the test failed and I got to fix it. Okay, that's not fun. Like don't think only about yourselves, think about people who are going to read and maintain the code, and probably that's your future selves as well. Okay. So that's with regards to my recommendations. And, this is the unavoidable thing on CI/CD, right? Okay, here's some advice. Save time. Basically, locally, just run test sort, to make quick check, that your tests are passing. If they're not, fix them. But, if, the tests are going to take like 10 minutes to run, just push them to CI, let it run and do something else, write some more code, don't wait for it. Again, if it fails, just go back and fix it. Right? But here's the thing, unit test failures are critical. If the unit test is failing, it means the unit is broken, fix it. Okay, integration and functional can be slightly more relaxed. I mean, maybe, as you're developing the PR, it's okay if, the integration test is failing because you're going to fix it later, you're making changes, factoring, etc. It's expected to fail. But of course, when it's time to merge, there should be no test failures. Okay, I know this sounds horrible given what we have, but we got to do it. I mean, we're not there. We got to work towards making sure that we have no test failures. All right, guys, basically that's all. Feel free to ask questions. The only thing I have to say in addition is happy testing. There is such a thing.
I can add something from my side, and it's about parallel testing. This is something that I think it's important because when we add more and more tests, and normally running those tests will become a bit slow. And because I think we are not running them in parallel. So another thing is, if we want faster tests, we could run them in parallel. However, this requires a bit of effort, and the effort is that
Yes,
tests should be completely isolated, and they should not, let's say, interfere with other tests data. For instance, why a global variable is a bad idea to share, for instance, between different packages. When you write a test and let's say one of you and they run in parallel, one of them, let's say, does some changes to the behavior of a global variable or a whatever state, and the other one tries to access it, and basically at that point you have some inconsistencies and flaky tests. So
yes, I agree with you. So basically, parallel is desirable, but it's not always achievable. This is not why I didn't make any recommendation. Also, the question about parallel is what parts are taking a long time. Usually it's integration tests, and if you've built your test kit correctly, you shouldn't have independence and you can run them in parallel. So for the unit test, the difference between taking 1 second and 5 seconds, yeah, maybe. Go short, taking 1 second and 2 seconds, not so much. I mean, if you have tests that take more than a minute, then definitely consider, running them in parallel if your test suite is taking more than a minute. But again, you should probably do the grouping so that you can serialize certain tests that may interfere with each other. But there's no silver bullet here, though. It's just desirable, but not always achievable. So that's why I didn't put a recommendation about this.
I have a comment for the developers that are reviewing AMR. It's important to see if the unit test is implemented and if it's following this recommendation and and if the coverage for the new chains are okay, if they have a good coverage. So please take attention when you are reviewing AMR, please.
I would like to add something on top of what Zanaina said. Basically, with the coverage, make sure that the happy path is completely covered. Air conditions, very desirable, but sometimes they're very hard to trigger. So if the code looks good, maybe you don't need to cover this, at least not at first. So when it comes to coverage, like I think we should strive to have at least 80% coverage. Like 90 would be great, but 90 is so hard to do. Because if you have a code full of if errors that, error that, error that, error that, and you have like 20 error cases to cover, then you're not going to get the 90% coverage. At least not at first. But yes, try to keep it at least 80%. Look at the code cove statistics. Before you say that you're ready with the PR, to make sure that you get adequate coverage. And remember, the happy path should always be covered. And I mean, it would be embarrassing if the happy path doesn't work.
Well, I have comments on both Janina's comments and your comment, Lisa. Regarding this, let's say 90% coverage, it is true that it's difficult, but then it becomes important, the code quality, that you don't have ifs, that you have to kind of test each branch of the if the tree or whatever.
No. I'm not talking about complicated if branches that explode exponentially. I'm talking about straight line branches, about doing something, checking the error, doing something, checking the error, doing something, checking the error. Straight line. Again, when you check the error, you immediately return, right? So ideally, you would like to check all of them, but you're not going to get them from the beginning. It's going to take time to actually write all the tests that check everything. So as long as the happy path is tested and some the general error failure strategy is tested, and we get like pretty decent 80% coverage, I'm happy with that. Although 90%, again, maybe we can do a push to achieve 90% test coverage if we have already 80% coverage and we have time, and we say, okay, we want to improve the quality of the release. We're in RC2, we're going for RC3. Let's make a push to increase coverage. But I mean, does this make sense? I don't want you to spend too much time increasing the coverage artificially.
But what I would like to kind of ask, if you agree with this, that I would say that even if we have this goal of having 80% coverage, we should not compromise quality of tests.
Absolutely. The tests, it has to be high quality. I would very much prefer to have 80% coverage with high quality tests than having 90% coverage from a jumble of tests that I cannot modify and maintain.
I mean, even if we get 80% of coverage with crappy tests, as you called it, it's not good enough. It's better less coverage with good tests than more coverage with crappy tests.
Yeah. I agree. Remember, the final recommendation: keep it simple. The test has to be simple, easy to understand, and maintainable. Otherwise, it's technical debt. You're going to have to deal with it until the end of time, and it's going to annoy you to no end.
And another comment is also related to what you said about tests. We are not writing, let's say, we're not writing these things for ourselves. Well, for future selves or for other people who are reading it, and the readability is important because people will review merge requests, and they should understand what exactly tests are doing so that they can.
It's not that. It's not just review. This is, it's really important because at some point you're going to introduce a bug with the changes that you're making, and the test is going to fail. You need to be able to very quickly understand the test and what is the bug, basically. Why is it failing? Because if you have to read a convoluted jumble of tests just to find why and where you're failing and where the bug is, you just wasted hours, and you got frustrated in the process. So that's not good. Be considerate. Future selves, your colleagues, the community at large, people, interested hackers that are reading your code, it should be clean.
Exactly. So I would also kind of introduce this context because we are with this release, we are basically introducing the code to the community, and we expect that we will get input from the community. So the efficiency of that input from the community depends on how well our basically test suite is done, because that will enable us to put that into a code and to leverage everything. So yeah, that's kind of important.
Yeah, agreed. Another thing, I have also seen a lot of people are trying to find how to use an API, and because they don't read the documentation, maybe the documentation is not that clear, they actually read the tests. I was surprised by that, but a lot of people read the tests to figure out how, how to use an API. So the test should be well written so that someone that reads the test for this purpose understands how to use the API.
And then I have a question, which is more specific about one flaky test. We have an example of a flaky test that, and I think Gabriel may be better to explain what's going on. I'm talking about this SSH stuff, which fails once in a week.
Okay, so maybe
Yeah.
there's a bug in the test in this case, right? Maybe you have a race condition with starting the server and like basically having SSHD running and you can't connect. Like that could be a possibility.
Yeah, I mean, sometimes the tests are, because there are multiple levels of tests that we're talking about, right? When we're talking about a unit test, it's more contained, it's more localized. But when we start doing integration tests or functional tests in a context of, for example, the P2P stuff that needs to access network, we start to relying a lot on infrastructure for that. And yeah, infrastructure can also interfere with tests in the ways that it's
there's unpredictability, and this is why I mentioned that you can be a little bit more relaxed in the policy of integration tests, because maybe in this case there's nothing wrong with the code. It's just like environment variables and timings, and random stuff happening, affect whether the test succeeds or not. So ideally you could restructure the test that is robust and doesn't have this kind of failures, but it's not always easy.
But I would like to make it more concrete in the sense that, so the situation that we have is that we have a test which basically uses SSH connection to the container. And from time to time, the public key authentication just fails.
Okay. Do you think there is a bug?
But the only way we figured out how to deal with it is to dump all the SSH logging onto the pipeline and to see next time when it fails and figure out then what to do.
Yeah, so I mean, this could be a bug potentially, but it doesn't sound like a bug. It sounds like an artifact of the test itself. So these are the hard cases with integration tests. Like it's not easy to make fully reproducible tests when you're doing integration and you're standing or you're doing system integration in a SRNS and you start processes right and left. There's a high probability of the test is not good enough to basically be robust to this kind of errors. But in order to make it robust, you need to understand what's happening. And right, yes, what you do, you put prints, and you see next time that that happens, Gabriel jumps on it and says, okay, now I see you and I know how to fix it.
Okay, so we basically did correctly then, Gabriel.
Yeah, you did the right thing. I mean, you have to debug the test at this point because you're not certain whether it's a faulty test or whether it's a bug. It seems more likely that it's a faulty test, but you have to make sure and fix it.
Yeah, sometimes, because of the nature of the problem, sometimes we don't have enough information, and we just have to dump everything and we also don't have the exact timeline when something happened. It could be like a chain of events, and to trace a chain of events inside a network of interacting components is sometimes hard, and you have to just dump everything and try to figure out later what's wrong.
Yeah, I know, been there. It's a nightmare. It may take days to fix this test. It's not a joke. Right, folks? Any other questions? If not, we can close and save 10 minutes before the next meeting.
Before that, I would encourage questions with a certain, there was a statement by Visa. We will, as soon as possible, we will basically fail pipelines if unit tests are not passing. And then we'll spend most of our times covering those unit tests. So, which means that it's like a call for action.
Yes, absolutely.
We asked in order to hear those tests correctly now, because we are starting to fail all the pipelines. Which we
guys, if you have written a test, you see it being flaky or failing, please fix it. It's important. And we don't want to stop the world right now to fix the tests, but if this doesn't happen soon, we're going to have to do it, and then it's going to be you getting assigned tickets. Fix this test, fix the test. So please, so we need to even fix it, without getting to that point. All right, folks. So happy testing, unless someone wants to ask a last-minute question.
So it seems that everything is clear.
All right. Okay. Happy testing.
Thank you, Vizu. Thank you, everyone. See you.